start seeing these vulnerabilities and being proactive in future threats. Then we kind of move into that cyber vulnerability aspect of this. We know that the attack threat surface is expanding with the evolution of AI. We know that a lot of these organizations are also looking to digitize their operations and modernize these operations. But you can't do so in current form today. So part of our initial focus is bringing in those assets through existing infrastructure. One of the biggest challenges kind of that these municipalities face is the rip and replace model that we have today. A lot of these municipalities and utilities don't want to add new sensors, widening kind of that attack surface. So we focused on using existing infrastructure to do so. And that allows for kind of the predictive analytics, the preventive maintenance aspects where they get to save money, and also that really involves them being able to now interact and engage with those assets. Just kind of a state of where we're at today, we're working with multiple municipalities. A lot of times we're handed multiple files of their assets. And these are XML files, and that is obviously very dangerous in the world that we face today, to not have total visibility over your operations. And ultimately, where we want to get all of these organizations is into the autonomous world, where they're taking these teams of 2, and we're multiplying them to being teams of 10 with this solution. So you can think if there's a vulnerability existing within an organization, let's say the IT team missed it. What our platform does is identify that vulnerability. We program in certain protocols based on how that specific organization deals with threats, and that allows our platform to remediate certain vulnerabilities with human in the loop. And that is kind of the agent platform that we're building and deploying as well. That also allows for them to engage with their data. And this is one of the areas where we see is falling short today. We get all of these different data points from our customers. They don't really know what to do with the data. So by bringing all of that into a centralized place and building essentially an LLM around it, they can engage and understand what to do next, when to do it, and why. And that is part of the digital twin advantage. So first, I'd like to kind of break down the digital twin. We hear the term a lot. It can mean a lot of different things depending on what you're building and who you're kind of working with. Our version of the digital twin is taking those hard assets and creating a virtual replica that also is feeding live data into it. What really stands us out is we're using physics-aware AI layer so that we can then take that data and then we look for the flow of electrons to see if there's a disruption. We look at different pH levels for water and wastewater to ensure that the operations are running smoothly and there's no injection of false data in there. So we monitor the physics-aware aspects in order to provide a full landscape of what's happening. A couple other things. So digital twins are useful across industries. We're also working with some military installations. Excitingly, I get to work with an installation I spent years at in Texas, and we're really helping them do the same thing. They share a lot of the same assets that the municipalities are monitoring. So we become a dual-use technology due to our ability to kind of deploy digital twins for different reasons. So just want to kind of give you an example of how we're really utilizing. There's a few different elements of what we deploy with digital twins. This is kind of the cost optimization aspect. So what we really do is take all the different PLCs, ICS, and SCADA systems. So we're not doing the rip and replace model, and then we put a layer between that model. And that layer between, depending on the objective, is what we're focusing on. So if you look here, operational costs or OpEx or asset lifespan, that would be programmed within that operations model so that the output that we're looking for is the goal that we set forth. So then it becomes autonomous in how we're solving the problems for different municipalities. Another aspect is the data access, which right now we're seeing all of this data across multiple customers. And it just sits within certain systems that they're not even evaluating. And by missing some of these different data points, it's not allowing them to make the best decisions in a timely manner. So we're bringing together all these different data silos, departmental silos, and bringing them into a centralized platform that runs analysis across all of those different data sets, providing them different valuable information to start being proactive with a lot of their operations. So just kind of to talk about the opportunity that Grid Catalyst has provided us in piloting with Grand Rapids. The objective of the Grand Rapids pilot is to really digitize their water and wastewater operations. They would like to run simulations in a virtual environment without actually interfering with their physical and live environments. So our pilot is right now going through all of their different control systems. And through integrating all of those different control systems and then putting that within our platform, it allows us to start analyzing their information to understand where they can reduce costs at, how they can reach operational excellence, and how they can actually focus on using data effectively in the future. And one of the big challenges across utilities, municipalities, is the ability to actually integrate and collect this data. As we all know, like there's no uniformity when it comes to these systems, especially a lot of these hard assets. Another thing is air-gapped environments. So we've been able to get around that doing multiple different techniques. So one-way diodes where information is coming only one way out. Deploying on-site historians that provides access for the organization to get that data in a secure way. And a lot of our customers, and a few of them, are looking at moving into cloud. So we really focus on integrating into SCADA systems. And that is how we've kind of been able to go around kind of that rip and replace model. And that is what we're essentially doing with Grand Rapids here. So really, like you see up there, one of the main objectives is that real-time monitoring and alerts for Grand Rapids and their water and wastewater treatment center. So we've worked over the last few months really identifying all of their different data points, all of their different integration points with IoT sensors, as well as any hard systems that we're working with. And we've made it quite a bit so far, gathering all of those different sensors. And that's probably the biggest challenge within a lot of organizations. So here next, we will be deploying the actual digital twin for them within the next about a month or so. And then that will start allowing them to start running these simulations that they're looking forward to, helping them kind of to reduce costs and monitor their operations as they look to digitize and bring all of these assets into a centralized location. And some of the kind of the ROIs that we're looking at for them, as you can see, is reduce maintenance costs. They say that right now everything is reactive. So when something goes out, was there a way that we could have been proactive in mitigating whatever loss that was? All in saving them future CapEx. And another big opportunity is that optimized energy consumption. So we're able to program in certain operations where they can turn their motors on and off depending on the need for it versus continuously running. So our platform allows for the optimization aspect as well for energy usage and consumption. And minimize downtime. they had some downtime last year that could have been prevented. And one of their future goals is to start mitigating any type of excess downtime through being proactive within their operations. So we're bringing in all of these different kind of techniques so that they can have this centralized platform to start running all of their kind of goals for the future as they continue to modernize their grid. And that's why Grid Catalyst has been amazing in connecting us, and we're also looking for more partners and more pilots that will allow us to kind of expand the technology into other use cases outside of just the water and electricity. Thank you. Time for questions. Yeah.
Do you have a sense for what would make a good next facility after this one, based on the work that you've done so far?
Yes. What we've really come to understand is what speeds up or slows down a project is the organization's ability to kind of control and understand what their goals are. So one project we were working on, we actually were looking at the wrong SCADA system for 2 weeks because one of their IT people retired and didn't fully update it. So the best, I guess, the most efficient pilots and partners would be partners who kind of understand where they're at today, their landscape, as well as kind of have that stuff collectively together. Yeah.
Are you pulling data from existing building automation supervisors or purely from like the SCADA systems?
Yes. So a little bit of both. So we have a project in New York where we're pulling from BMS systems, building management systems. But when it comes to getting real-time data, it's best to have from the SCADA system, the same system that they're making the decisions from. Yeah. Yeah.
How much of the experience for the user is driven by the consultant working with them to use the app, and how much is purely the app driving? Does that question make sense?
Yes. It's a great question. So what we've decided to do, being that it's a challenge to start getting all of this information and what to do with it, we have this utility launch program where that is the bulk of kind of that consultancy aspect and the service aspect, where we're kind of training them on their goals and what they will see once the platform is up and running. But once it's live and deployed within their environment, they're already aware of their goals, and it runs autonomously based off of sets and configurations. Yep.
If you had a magic wand for organizational incentive structures, what would you want to see change?
I would say, it's a good question, because there's a few things, but most importantly, organization within their networks initially. Right now, it's very fragmented. So kind of to your question, initially, that is the bulk of our time, trying to identify, one, the strategic goals that they have, and two, what do those strategic goals involve from an asset perspective. So we're coming into a lot of organizations helping them with that initially, where I think if organizations started focusing on that now so that they can go out and find the innovative solutions from the onset would be ideal. All right. Thank you.
Thank you, Dwayne. And for the next startup, we're going to do a little something different. So you'll hear from both the startup and the pilot host. Diana Fisler is here from Ecosnap, and they are installing their mini-split units in a building that is owned by Precipitate. And Elizabeth Turner is here, the founder of Precipitate, and they're experts in high-efficiency building technologies, really on the forefront. So it'll be great to hear a perspective from both of them.
Okay, so we're going to zoom out really quick, and then we're going to zoom into just the building scale and talk about why electrification is an issue and what we can do about it, and how Ecosnap can help. So I'm an architect. I do a lot of new construction primarily, and a passive building consultant. So I do a lot of energy models and figure out how we can get buildings to be net zero. But I had the opportunity to be one of the consultants on the Minneapolis Climate Equity Plan. And looking at the data really helped me understand how existing buildings, and particularly in the commercial industrial sector, are the biggest issue. And Luke has made these first 2 slides, so ask him more questions. But here's the crux of the issue. So we are decarbonizing electricity in the city of Minneapolis. This is data from 2024. Not so much for fossil gas, and it is very weather dependent. And this is really difficult in commercial and industrial applications, especially because there's a lot of other economic factors that impact this. It's not just about like a homeowner deciding they want to electrify their building and purchasing renewable power or solar panels. It's very complex, and even like the financial structure matters. So I decided, this is like the next big issue. We kind of have new construction figured out. What are we gonna do with existing buildings? It's been a really complicated project. We bought a building in Uptown for our office 2 years ago, and put together a 10-year plan of how we could decarbonize that building and do renovations to increase the energy efficiency, going all electric, doing new mechanical systems, replacing the windows, and doing continuous exterior insulation. And then the climate really changed, and everything broke all at once. So we are doing a 2-year version of that 10-year plan, and I'm really, really grateful that Diana and her product is available, and that Nina connected us through the Grid Catalyst pilot project. But I'll let her talk about her product first.
Sounds great. So I know this is a pretty elite crowd, so I want to know how many people know what a heat pump is? The entire room, I think? How many people? So 5 years ago, if I said heat pump, regular average people often would not know what a heat pump was at all. And I think things have really changed a lot, even in the last couple of years. So I don't have to belabor what a heat pump is and why it's so special, but I do want to point out a couple of things. The technology we're talking about today is air source heat pump, air to air. And I'm also talking about single zone ductless mini split heat pumps. How many people know what that is? Fewer, I'd say fewer. So air to air, so the source of the heat is the air outside. It's delivering to a single point of delivery of heat and cold. You all know heat pumps can heat and cool as well. And then the other special thing that makes it important for Minnesota is in the last 10 years, the technology for residential heat pumps has dramatically improved, such that inverter-driven compressors can operate very efficiently down to really low temperatures. And Ecosnap has done some work with Fairbanks in Alaska with NREL and looked at performance all the way down to -20. Some Alaskans have looked at it, and the heat pumps don't even stop working down to -40 F. Now, you might not like exactly what kind of performance you're getting at that level. Maybe you're starting to draw more energy, but they will work, and they will work pretty efficiently down to some pretty cold temperatures. So that's all we're going to talk about heat pumps in general. How do I change, Elizabeth? Is it this one? Is it this one? It's the arrow. Okay. So just this is always a startling look, We should not be burning gas or oil in our homes anymore for heating. The technologies exist. They're very mature for heating and then bonus cooling in most climates. And as Elizabeth pointed out, as the grid gets cleaner and cleaner, the emissions impact of using electric heating, and in particular heat pumps, gets better and better. So this is the right thing to do. Now let me talk to you about Ecosnap. Ecosnap was born from my own anger. I asked for a quote from a local HVAC person for my home office for a mini split heat pump, and they said $8,000. And this is in Colorado. And then I asked for a quote for a duplex I own, and someone said $10,000. And I said, you know, I'm just talking about one piece of equipment, right? And that's the reality in many parts of the country. So I dug into what's the problem. And it's really very much a technical and a market problem. So market is uncomfortableness with new technology. But on top of that is that there's a complicated evacuation, charging, and line set running step to putting in a heat pump. And so we set out with clever engineering. We're not reinventing the wheel here. We're not doing rocket science. We're just employing clever engineering to remove some of those bottlenecks. And that's what Ecosnap is all about. There's one of our very early prototypes in partnership with Oak Ridge National Lab. The blue was my idea. Everybody wants gray. So I was overruled. And so here's what I just touched on is labor in the field counts for the vast majority of the price of a heat pump. And that's true for central heat pumps, and it's true for ductless mini splits. And so I got to looking at that, and I created a stack chart, and I found out the evacuation and charge and running of line set, and we said, how can we tackle this? You can actually get a heat pump out of China for a number that would shock you all, and you would be upset to know that you can get a heat pump for like $250 out of China. So why does it cost me $8,000 when I go to get one in my office? So enter Ecosnap. So we have a product that enables faster, more profitable installation. And this can benefit either and the homeowner and the HVAC installer if they choose to use an HVAC installer. Faster, more reliable, and cheaper installations is what we enable. We reduce install time by 80%. Based on compared to traditional install. Fewer callbacks because our system is more leak-proof. So you're not going to end up with climate-changing emissions going into the atmosphere and in a more immediate sense, something that impacts the performance of the heat pump once it's in the homeowner's home. So there's more opportunities. Potentially handymen can install these or handy homeowners. And then the feature that I'm going to touch on in the next slide is we have also engineered it so that it will run on 115 volts. And so it would be plug-inable, so you can put it into an outlet on the inside. That's not the only embodiment of Ecosnap, but it's an important one for smaller homes. Here's what the technology looks like. First of all, it's based on 2 licensed patents out of NREL, funded by the Department of Energy. We have an exclusive license on that. You can see there the air handler on the right, the exterior wall, and then the outside unit is mounted on a bracket on the outside with this connection between the two. These low-loss fittings, refrigerant fittings, which can be seen here, right here, come together with a snap, so Ecosnap. And a lever connects all the functions. So the data, the power, the condensate, and the refrigerant lines are all connected by a single throw of a lever. And so that's the magic of it. And again, it's not magic, it's not rocket science, it's simply very beautifully engineered. And so we're trying to, and I believe have succeeded in foolproofing the installation and bringing it down to just a few, less than an hour, a few minutes. What else do I want to say about that? Oh, I think that's good, we'll move on. Here's our history. We built the MVP based on a laboratory research scientist version and made it practical, made it manufacturable, made it cost effective. We've been supported by your own Grid Catalyst program, and we're very grateful for the relationship that we've developed with Precipitate. But we've also partnered with NREL and Oak Ridge, the Launch Alaska team in Alaska, which allows us to show if it can work in Alaska, it can probably work in Minnesota as well. We've demonstrated the technology in 5 different climate zones. We've had homeowners install them, we've had GCs install them, and HVAC technicians. So everybody's giving us feedback, and every single install, we get a little bit more information and tweak it to make it so that it's IKEA-like. Like, this is going to be so easy for you. You don't even have to think about it. And then finally, I just want to address a question that comes up a lot. So I looked at the design temperature in Minneapolis around 0 and pulled up the specs here. An important thing about Ecosnap is we're an installation technology. So any performance that is available can be available through Ecosnap. But what we currently have is the performance that's shown here. So the coefficient of performance at minus 13F is 1.55, and at 5F it's 2.51. So the performance at your design temperature is somewhere between 2.5 and 1.5. And then back to you, Elizabeth.
Great, thank you. So let me tell you why I really love this technology for this application. This first floor space, one is Lala Ice Cream, and next door, just opened last week, is Thesis Coffee Company, so please support them. They're in an all-electric building, and it's going to be really energy efficient. But the upstairs units, so they have like large commercial systems that are all-electric and lots of ventilation with energy recovery. The upstairs units used to be single-family homes. I love this photo because if you can see, this is a 1931 drawing, and they have like just an electric fireplace. This is one of the locations we're going to put this new Ecosnap unit for heat and cooling. I think it's really important to think about like the economics of reusing buildings. Doesn't necessarily make sense. It's more expensive to get to all electric. When you're building new than it is with renovations. However, embodied carbon is a really important part of this. And the other piece is just like our old buildings are beautiful and we love them and we want them in our urban fabric. So this is right on Hennepin Avenue. And it has a historic Art Deco storefront, and we're going to preserve that. I also really wanted to preserve this interior. There's some historic plaster friezes up there. I didn't want to put a lot of ductwork in there. I also didn't want to disrupt the tenants, because when you disrupt tenants, then you're not earning rent for that time, so that's another part of the economic equation. And I wanted it to be all electric and be able to kind of move away from fossil gas in a way that is still affordable to operate, so heat pump technology lets us do that. Some challenges that we've seen, so in purple here, this is where the Ecosnap units are gonna go, 4 of them. Even though we're just replacing the electric, the baseboard that is powered by natural gas boilers with electric, we had to design so that the full load could be all electric. So the most expensive part of this install is wiring for the electric resistance heaters. Those are all the ones that you see in red. There were gonna be 3 times this many until we decided to do the extra insulation and new windows at the same time. So we got this down a little bit lower by thinking about the envelope at the same time. But we're also going to be required to put in ventilation at the same time as the new heating system, which is a challenge because we have money for the heat pump to change and not necessarily ventilation at the same time. So those are some like regulatory things and kind of just like basic engineering things that we hope that this pilot project will help address. You know, we're gonna test and actually see CEE is going to study how often the actual electric resistance heaters turn on. And that will help us know for future projects, do we really need all of these electric resistance heaters? Can we take out the boiler and replace them? And I think that what's making this really possible now is partnering with Diana and having this really great coefficient of performance available. But we're also working with City of Minneapolis Green Cost Share, Energy Smart at the Minnesota Chamber of Businesses. No, Energy Smart is with Chamber of Commerce, thank you, and the CEE grant and others. So it's been really in Minneapolis Green Cost Share program. So those are really going to help us kind of test out these new technologies and see how they work in Minneapolis.
May I add one thing? We've had a lot of interest in our product for residential spaces, you know, workshops, 3rd bedrooms, small dwellings, accessory dwelling units. I'm so grateful for this opportunity to partner with Precipitate because it allows us to demonstrate in light commercial, which is also a big application. And like Elizabeth said, the ability to monitor and demonstrate how much the resistance heat is used is going to be really great for future projects for everyone in this area. Thank you. Any questions? You want? Okay, I'll keep it. I see that one.
Thanks, Elizabeth. Can you talk a little bit more, you mentioned this, about regulatory challenges, particularly with new technology?
Yeah, I think it's regulatory. I think it's also like we're in a building as a liability heavy profession, right? So like even if something might get past regulatory, it's like, if I use my engineering license to say to the city, this is going to pass, and there's a complaint, like what does that do to my reputation? So those two things are really tied together. So I think the biggest hurdle from the city has been the requirement for ventilation to happen at the same time as a heat pump replacement, because there was no ventilation in here. There's not even in a bathroom exhaust fan. The exhaust is opening a window.
So how does your ventilation system work?
So we were going to do a Lunos kind of through-wall system, which is kind of cool. That was a regulatory hurdle. They kept asking questions and questions about it. Meanwhile, we don't have any heat in the building. So we're like, okay, we're going to do a typical energy recovery ventilation system. You can see it here. It's located in this closet. So I kept the duct really small here. So we'd have to only build one soffit and then build down this hallway here a little bit, and it'll exhaust from the bedroom and supply to the other room. So very typical ERV. But the ventilation recovery is really important to making this work too. Yeah, in the back, yeah.
Perfect, thanks. This is amazing, and I saw you present last year for your Ecosnap product. So amazing to see where you've come, and I love this real-life example. Just a quick question tying back to an example or something that Nina mentioned earlier in the day. When you got the patents from NREL, what TRL level were you at, and how much work you had to do to get to where you are now, just to give everyone kind of an idea of what that looks like from the startup standpoint?
Yeah, I'd love to share that. Because I would say that it was at TRL 4 when we got it from NREL. So they had demonstrated a couple of times in the lab, but it was truly not manufacturable. Like it would have blown any kind of marketing budget out of the water. Market-based, I guess I should say. And so now we've deployed in multiple real-world environments where we are currently operating. So I estimate we're at TRL 7. And we're currently looking at scaling up. So if anybody here is in hard tech, that chasm is no joke, right? And so it's one thing to hand build a piece of technology in your garage or your engineering shop, and they can do 10, but when you try to do 100, when you try to do 1,000, the resources for that are really, really hard to find. And there's a handful of organizations that support hard tech, and we are so grateful for those. I mean, Grid Catalyst for hooking us up with Precipitate, the Rocket Fund out of Caltech, M-Hub in Chicago has been tremendously helpful. But that scale-up chasm is one we're constantly butting our heads against. But yeah, 4 to 7 is what I would say. And we've been so lucky to work with early adopters. Any other questions? Yes, sir.
Yeah, I was wondering if, so in this diagram, it looks like all the heat pumps are just directly through the wall between the outdoor and the indoor. Is that required with Ecosnap?
Yeah, so we're sort of removing a lot of complexity by requiring them to be co-located. And I'll be frank with you that there are certain markets that won't support something mounted on the outside wall. We're thinking more like HOA type middle-class suburbs. They don't like the looks of it. We have some plans for how to increase the aesthetics of that outside unit, and we've done some work with our NREL partners on how close and snug to the wall and sleek we can make it look. But that is part of the trick. Part of the trick is keeping that constrained. And so, yes, they are currently co-located. Now, the Quick Connect technology, my CTO is currently working on making that more flexible. But our first challenge, I don't mind telling you, was how to adjust to different wall thicknesses. And we have what I think is a very clever approach having to do with a helix. And that's one of our provisional patents that we filed. But adapting to that without giving up the benefit was a big challenge that we solved. And that wasn't, to your point back there, the original NREL technology had not addressed that either. Yes, please.
Yeah, so one of the things that I really love about this technology too is if you work with heat pumps, one of the drawbacks to them is that the refrigerants that are used are actually contribute to climate change. So this amount of refrigerant is really small, kind of like the least amount that it can be. So when Diana is talking about leaks, it's also not contributing to greenhouse gas emissions quite as much as other technologies could. We have had regulatory hurdles with that too. If the units were mounted down on the ground, kind of at the back of the building, we could have installed them more quickly. We're going to have to install roof anchors for the safety of the guys installing this, but I think it's worth it for the reduction in refrigeration too.
Yeah, I'll point out a couple more things. It's actually really good to have the outside unit mounted up on the wall. It can be protected, not in this building, but in many buildings from heavy snowfall, and it doesn't get all leaves built up in it. So it's actually a really cool place to have it if we can surmount the occasional aesthetics problems, objections. Yes, sir.
So your connector, you don't need to have somebody evacuate the refrigerant system. That connector, you wipe it off with alcohol to try to get it really clean?
Refrigerant oil on the front. We didn't know that at first, actually, and so it turns out that's a best practice.
So maybe that's patented too then?
We found it in an installation manual by one of the OEMs, so no, I don't think I can get that one.
But the whole idea is you get things cleaned up. It does not need to be like vacuum, 30 inches of vacuum.
That's
something
right.
Like that. You get it next and pull the lever and everything.
That's right.
Snaps together and valves open up and you don't have a lot of restriction in that valve either.
That's right, yeah. And what Elizabeth said about less refrigerant, I was thinking about it as a cost reduction. Like, that's 25 feet of line set of refrigerant that you don't have and you don't have to pay for. So there's a lot of ways that this is an advantage, and this way of doing mini splits is the right way to go. Any other questions for us? Yes, sir.
Just a quick question. You went to baseboard electric heat. Was there any reason why you didn't do just like an electric boiler versus?
Yeah, so this building, all 4 units, the coffee shop plus the upstairs ones, were all on the same thermostat. So the way that it was being heated last winter was one unit would have it 77 and everybody else would open up their windows. So it would have been, like $20,000 to replumb everything and separate the thermostat system. So that was a big part of it. It was also, this is a 1930s building. They were kind of at the end of their useful life, so they would have had to been replaced too. And I don't think it's easier to monitor. Like, we can put devices on these and know if they're running or not.
Any other questions? So one other thing, we haven't talked about this a lot, but we have a partner who has a thermostat that controls mini splits. So it's a thermostat that goes separate from the mini split, and it has demand response capability built into it. And so that's one of the things we could talk about looking at is there a potential to load shift with these units as well? And that extra thermostat addition to the project is trivial. It's a few $100s, but that's available to scenarios like this as well. Anything else? Oh, yes, ma'am.
So a detailed question around the regulatory hurdle. Did the ventilation requirement only come in after you decided to do the air sealing and window project?
No, but I think tying ventilation to air sealing makes a lot of sense. I think tying ventilation required to changing out a boiler for a heat pump doesn't make sense. Yeah.
Did you try to get a waiver on that?
We're trying, the equipment broke, so the air conditioner broke, and the heating is non-functional, and we disconnected our natural gas because we need to install a new window because it got broken. So no, we were just trying to get heat before we really, really need it. Yeah. But yes, that would be great to do in the future if you have more time.
Anything else? I think either of us, oh, yes, sir.
With them being mounted in elevated positions, I was trying to think back to what the actual unit image looked like. Do you have any issues with your coil clogging due to airborne particulates? With specifically if you need cottonwood, because it looks like it's a side discharge.
So it does require regular maintenance for that, and you're right that because we have cottonwoods in Colorado as well, and I have seen some build up there. But it can still be accessed. You want to describe that ledge that you have?
Yeah, I think this application is pretty cool because there's a little ledge here that you can crawl out these windows and stand on to access them. So you'll be able to go up there and clean them. Yeah.
So I will say that we're interested in multifamily for our technology, and we are worried about accessibility for cleaning if it's up 5 stories or 10 stories or things like that.
But I think it'd be the same as cleaning windows too. There's a solution.
It's might be a little more. I don't know. I'm just thinking about my side discharge, and it's a little bit. It's laborious to try to clean out the coil, and it was one of those things that I was looking at, and I was thinking, well, if this was 2 stories up, it'd be, or 3 to 4 stories up, it'd be quite difficult. So just an application-specific thing that could be a product improvement.
Yeah. Yeah, we're thinking about that, and you're absolutely right. Anything else? Yes, sir.
Have you thought about just a plain magnetic peel-off filter? You know, instead of running it past the coil, just having a magnetic filter that sticks up to filter the cottonwood before it even gets to the coil.
Like a really coarse filter so it doesn't
Yeah.
impact airflow.
Right.
We've thought about some of these things. We haven't implemented these things, and I think there's many cool technologies we could do. We've got a few provisional patents around things like that. How do we make this better looking, more comfortable, easier to maintain, all kinds of things. I think there's tremendous opportunity. Thank you.
Thanks, everybody. Thank you, Marianne. How about that? No? All right, I'll just be loud. Thanks, everyone. Nina Axelson, president of Grid Catalyst. I just want another round of applause for our 2025 startup. As I mentioned in the opening comments this morning, startups run lean and mean, and they put their whole heart and soul and a lot of their life on, to make this work. And so give them a high five, buy them a Coke, try and help them figure out how to get commercialized. It's the call to action we try to put out there all the time. And before we wrap up, because I want to give you travel time to your next sessions, although I think you should stay here because this one's going to be great. Just a reminder that we can only do this work with the pilots because of Minnesota Energy Alley. This was 2023 legislative action that originally was going to fund 2 cycles of startup pilots with Minnesota partners. We're really excited that because of how things went the first 2 years, we actually have a 3rd year coming up in 2026 funded by the same program. And mentioned this morning, 11 pilots mobilized out of the first session, and then we've got 6. And Peter, just say hi. Remember, if you see anybody in a green lanyard, that's one of our finalists for 2026. Go talk them up. Go ask them all the hard questions you're asking them, but also try and figure out how we solve these problems so this technology can get into the marketplace. So I am the super fan forever of all these great innovators and appreciate all of you in the work that you do to try and make this come together. And that's all we have for this session. Next session starts at 2. Matt's here, Carly's here. We're gonna have a great session in this room at 2. Thanks, everybody.